Following on from the previous video, in order for us to move on, we need to be sure that you understand the following. Well, you need to understand this, okay, and then you also need to understand this. And remember, whenever you see this, it represents the average height of the function in between a and b. So this thing here is the area of this whole thing divided by the width here. That represents the average height. So whenever you see this, in your mind, think of it as being the average height of the average height of this function between a and b. So whenever you see this, think of the average height, okay? And then the other thing that you should understand is this. Realize that there must exist a c where our average height lies. So remember, whenever you see this, it represents the average height. So this thing here is this average height here. Okay, so whenever you see this, it represents the average height. But this here is saying that there is a place in between a and b where our average height lies. In this case, there is a place somewhere in between a and b that our average height lies. Okay, so this you should realize, you should know. Okay, you should understand before moving on. And the other thing that you should understand is this. So our average height is somewhere in between here. So there exists a c. You see this here. So this place here is there exists a c where our average height lies. Now the thing is, if you decrease, so this here is h. Hang on, this here is h. Okay, if you start to decrease h, so let's say b is no longer here. Let's say we're going to decrease it. So we are going to move b to here. Okay, so now we are now going to decrease h. So the point that we're trying to make is we're trying to take the limit as h tends to 0. But let's just decrease h slightly and see what happens. So as usual, we would get the whole area, and then divided by the width here. That will then give us our average height. So our average height between a and b lies, I don't know, let's just make it up. Let's just say somewhere here. So there exists a point in between a and b where our average height lies. Okay, so this is our average height here. So in this case here, this is our f of c. You see, there exists a c somewhere in between a and b where our average height lies. So this is our average height. Okay. Now let's decrease b even further. Sorry, let's decrease h even further. So now we are decreasing h. So b is right here this time. Okay. So this is our b now. So our normal routine is to get the whole area. So that's the integral here. That the whole area is this. The whole area is this, and then divided by the width here. So our normal routine is to get the whole area divided by the width here. So that's this, and then this here represents our average height. So in between a and b, let's just say the average height of this function is somewhere here. Okay, so somewhere in between a and b, there must exist a place c where our average height lies. So this is our c. So you see that somewhere in between a and b, there must exist a value c where our average height lies. So our average height lies right here. Now decrease h even further. Let's say to here. The point is that hang on. So let's move b to here. So now our normal routine is to get the whole area divided by the width, and then that would represent our average height between here and here. So let's just say our average height lies somewhere in between here. So there exists a c somewhere in between a and b where our average height lies. The point I'm trying to make here is that as you decrease h, remember h is this thing here. As you decrease h, let's say you decrease h to around here. Then this here is our f of c. The point here is that as you decrease h, f of c becomes f of x. It has no choice. F of c has no choice but to lie on top of the function. So f of c becomes f of x as h tends to 0. As you take the limit of h, as h tends to 0, the f of c becomes f of x. It has no choice but to lie on f of c has to lie on top of f of x as you decrease h. As h tends to 0, f of c has no choice but to lie on top of f of x. So you can say that f of c equals f of x as h tends to 0. Don't forget, this here is the average height. This here is a height. This here is also a height. These two heights will equal as h tends to 0. Okay. This one here, you have to understand this in order to progress. Okay.